Bismillahirrahmanirrahim. Assalamu alaikum, dear students. So today topic is about the mean deviation and its coefficient. Last time we have covered the range and the quartile deviation. The major flaw of the range and the quartile deviation is that they did not cover the entire data set. The mean deviation now it's covering the entire data set. Look at here. We have the two formulas for that. It's a mean deviation from mean. When we take the deviations of the observations from their mean, it's called to be the mean deviation about mean. And when we take the deviation of the observations का मतलब entire data set, entire x value, सारी की सारी, from its corresponding median, it's known to be the mean deviation about median. So the disadvantage basically is that this absolute you can see over here, the two modulus, the two vertical value called to be the mathematically modulus value. मतलब कि हर नेगेटिव डेविएशन को भी वो पॉजिटिव कर देगा. सो बेसिकली ये डिसएडवांटेज है हमारे पास मीन डेविएशन का, बट ऑल्दो इट्स कवरिंग द एंटायर डाटा सेट, सो वी कैन यूटिलाइज इट. सो देयर आर टू बेसिकली टाइप्स. वी कैन कैलकुलेट फॉर द मोड एज वेल, बट you will use two types: mean deviation about mean and mean deviation about median. That's it. The next is going to be the coefficient. As we have already discussed in the range and the quartile deviation, that the coefficient of anything, it's a range coefficient or the quartile deviation coefficient, and similar to the mean deviation coefficient, will be a unit-free number. Unit-free number ka matlab pure number. You see, it's a relative term. How we can calculate? The mean deviation calculated by any Meyer central tendency in an absolute measure. Okay. For the purpose of comparing variation among different series, kindly keep in mind for the different series which are expressed in the same or different units. This is a big advantage of the coefficient. क्या मतलब कि अगर तो हमें सेम डेटा की दो डिफरेंट डेटा सीरीज की वेरिएशन को कंपेयर करना हो या सम टाइम हमें डिफरेंट यूनिट्स को, तो फिर हम क्या करते हैं, और अ रिलेटिव मीन डेविएशन इज रिक्वायर्ड. हमें फिर रिलेटिविटी की तरफ जाना पड़ता है, बिकॉज रिलेटिव टर्म जो होती है हमेशा यूनिटरी होती है, प्योर नंबर होती है, और वी कैन इजिली कंपेयर. यानी आई कैन से 2 is greater than 1.5. yes, because 2 is a pure number, it's a unitary number, and 1.5 is a unitary number, so I can compare it directly. But for the two different data set, I cannot compare it. The coefficient of mean deviation is obtained by like this and this. Coefficient of mean deviation from mean. First of all, we have to calculate the entire mean deviation from mean and then divide it by corresponding mean. Okay, so we will get its coefficient. And here the coefficient of mean deviation from median. Firstly, we will calculate the mean deviation from median and divided by median. As you know, if we are calculating from the same data set, the units will be cut off mathematically, numerator and denominator mein, and we will get the pure number. So that was the phenomenon which we have already discussed in the last lecture, but it was the continuation for that. And now we will go for one example. Kindly have a look. And they were saying for this data set, number of the faulty items and its corresponding frequency to that. Calculate mean deviation about mean and its coefficient. Our quality control inspector has recorded the number of the faulty item produced on an assembly line for each of the first 127 working days of the year. The figure are recorded in the following frequency distribution. They are the faulty items. Okay, जी quality assurance cell वालों ने किया, and corresponding frequency उनकी इस डे क्या हुआ, जो जीरो फॉल्टी आइटम कितनी, उनकी corresponding frequency 17. ठीक है, प्योर जो बिल्कुल ही परफेक्ट थी. फिर 1 डिफेक्टिव, फिर 2 डिफेक्टिव, फिर 3, फिर 4, 5, 6, 7 ये corresponding frequency के साथ the data set is given. Okay. One thing should be clear over here, students. This is a discrete kind of variable. Faulty items है ना, या तो no faulty item, या 1 या 2 या 3 या 4 या 5, according to the engineer's specification, we have to fit in over there कि ये faulty है कि नहीं है. ठीक है जी. तो कितने हैं हमारे पास ये jumps होंगी, 0, 1, 2, 3, 4, 5, 6, 7 या maybe 8, 9, 10. But there cannot be 0.5, 1.5, 2.257, means to say continuity नहीं हो सकती. There should be the jump. Whenever there is a jump, whole number data set, we have it in the hand. So it seems to be the discrete variable. Quantitative discrete variable है ये, ठीक है? और ये distribution भी हमारे पास एक discrete distribution है, continuous नहीं है, although it's having the corresponding frequencies. So this is the discrete frequency distribution. Kindly keep it in mind. I just revised the things again and again that if somebody has missed, तो उसको भी clear हो जाए. But ये बड़ा basic concept है हमारे पास कि quantitative discrete variable क्या होता है और फिर उसके corresponding frequency क्या होती है. हमने continuous की बहुत examples की भी हैं और बनाई भी हैं. But this is the example of the discrete frequency distribution. Okay, we have it the x value, variable of interest, which is the number of faulty items and corresponding frequency f. So हमें करना क्या है? हमें निकालना है जी mean deviation about mean. Have a look. First of all, for the formula, we have to look it back and see okay, what is the major requirement in that. ठीक है जी, हमारे पास major requirement थी क्या? Major requirement was that कि we have to take the deviation. अगर हम mean deviation about mean की बात कर रहे हैं, x की उसके corresponding mean में से, and similarly इधर x की corresponding median में से. Kindly keep it mind this formula in your mind, and then continue with the example. So we need to calculate first of all its corresponding mean. इस distribution का हमें mean निकालना है, which is by definition f of x, summation f of x by summation f. So we got it 3. This x bar is representing 3 faulty item on the average. The next is we have to take the deviations like this, x minus x bar. It means x is 0 here, पहली observation पकड़ी, minus corresponding mean जो हमने calculate किया 3. Certainly we will get -3 answer, but due to this absolute, this modulus, we will get 3. As I told you, कि सारी की सारी deviations जो हैं वो इस modulus की वजह से positive हो जाएंगी. Positive तो already positive रहेंगी, जो negative होंगी वो भी positive हो जाएंगी. So in that way, we have calculated all these deviations, x minus x bar modulus 2, 1, 0, 1, 2, 3, 4. And then we need to multiply it with corresponding frequency, means f times x minus x bar ka modulus. X minus x bar ka modulus, we have it 3. So 3 into 17, we get it 51. Similarly, 2 into 12, we will get 24, and so on. By the end, we have to take the sum of that, which is 188, is the sum of the corresponding column, summation f times x minus x bar over here. And we need to divide it by the total frequency, which is 127. It's over here. We substitute the values and get the mean deviation from mean, which is 1.48.
Thank you very much for watching my video.